I know that you guys feel like I'm going to be in section 1.4 until the end of time. And I won't, I promise. We're almost done here. We got a few more videos on the topic. I won't spend this much time on everything, but this concept of divisibility is so important. It's what most of y'all are missing that makes things like fractions and algebra and factoring so hard. So I really want to hit this hard while we're here. So I'm going to teach you a couple of advanced divisibility tricks now. I'm going to teach you the trick for 4's and for 8's. So one thing that we should realize in order to be able to do the 4 tricks is that the number 100 is divisible by 4. And if you don't believe me, I'm going to go ahead and prove that. So let's make sure 4 goes into 100 evenly. 4 goes into 10 twice. That's an 8 with a remainder of 2. Drop that 0 there, and 4 goes into 20 5 times perfectly with no remainder. And I'm sure you guys remember that if you have no remainder, that means that you are divisible. And so this idea that 4 divides 100 perfectly is what's going to lead us to the 4's trick. So let me tell you what the 4's trick is, and then we'll get started. So the 4's trick is going to remind you of the 2's trick, and it makes sense because we know what 4 is made of. 4 is the same as 2 times 2. Because of that, 4 is going to behave much like a 2. So you can remember that 2 was a final digit trick. We said if the last digit is divisible by 2, and how did we know that it was even, then the entire number, I should spell out number, huh? Getting sloppy today, is divisible by 2. Okay, so that leads us right into the 4's trick. A 4 is made of 2 2's, and so instead of just testing the last number, we're going to need to test the last 2 digits. So the 4's rule is this. If the final 2 digits are divisible by 4, there we go, that's the number I'm working with. Woo, I flaked out on that. If the final 2 digits are divisible by 4, then the entire number is divisible by 4 as well. Okay, let's see this play out in action. I know every time I say a math rule in words, I confuse everybody. So let's take a look at what the heck am I talking about. Let's do this problem over here. I've got the problem, is 758 divisible by 4? And so to put this rule into action, what we're going to do is we're going to break off just the final 2 digits of our number, 758, and I'm just going to do long division with that. And a little depressing, I know that you're going to have to do long division. That's why we're calling this advanced divisibility, guys. But at least it's only going to be long division on 2 digits instead of 3, 4, or even more. So I'm going to go ahead and I'm going to divide 58 by 4 and see if this works out for me. 4 goes once into 5 with a remainder of 1. Drop my next digit. And you can probably already tell 4 does not go perfectly into 18. Goes in 4 times, but I'm still going to have a remainder. Ooh, I'm moving in on my next problem. Got a remainder of 2. And so when there's a remainder, we do not have divisibility. And so the answer to this question is no. 758 is not divisible by 4. Okay, let's look at that in some different wording here. Same basic question we had said, is 2,367, a multiple of 4. Another way to ask the same question, so we're going to answer it the same way. We're going to take 67 and divide by 4. Now, a lot of you guys don't even need for me to do this division. You're already seeing that this is an odd number, and so this is not going to work out. But if you're not able to see that, I'm going to go ahead and prove it to you. 4 goes into 6 once with a remainder of 2. Drop my next digit. And 4 goes into 27 6 times. And my remainder here is going to be 3. 27 minus 24 is 3. So again, we have a remainder. And so the answer to this question is no. Okay, obviously we need to have a problem where things work out. Let's try this next one. Again, slightly different wording, same basic question. Is 4 a factor of 3,372? The smaller number in divisibility is called a factor. So again, just going to break off my final 2 digits and check if 72 divides by 4. It's even, so the chances are looking good, guys. Let's check it out. 4 goes into 7 once, remainder 3, drop a 2. And does 4 go into 32 perfectly? Indeed it does. Hallelujah, we found one. So is 4 a factor of 3,372? It sure is. No remainder. Great job. Okay guys, we're still going to talk about the divisibility trick for 8, but once again I say if you don't practice it, you're not going to remember it. So I suggest you pause the video, head on over to Quizlet, and check out set 1.4K, divisibility tricks for 4. Again, do it in learn mode, and try out the tricks I just taught you. It's easy when I do it, but how about when you do it? Last divisibility trick we're going to talk about is the trick for 8's. And once again, if you know what a number is made of, you're going to know how he behaves. So if I go ahead and pull 8 apart, I happen to know that 8 is the same as 4 times 2. I'm sure you guys agree with me. But 4, if I pulled that apart one more time, is just made of 2 times 2. And so what I see here, and don't worry, I'll teach you this neat little trick in one of the other videos. But what I see here is that 8 is composed entirely of 2's. Because that, he's going to behave much like a 2 does. So I'm going to remind you of the first 2 divisibility tricks that we learned about these similar numbers. The first was 2's. We said if the final digit was divisible by 2, then the number itself is also divisible by 2. Similarly, the 4's trick said if the final 2 digits are divisible by 4, then the number itself is divisible by 4. So you can imagine that my 8's is going to follow the same pattern, except because it's got 3 2's in it, I need 3 digits. And so the 8's rule is if the final 3 digits are divisible by 8, then the original number is divisible by 8 as well. So once again, you guys are probably cross-eyed because I'm throwing so much math speak at you. Let's go take a look at a problem to see what the heck I'm talking about. Okay. So I've got a sample problem here. It says, is 58,224 a multiple of 8? So when we're checking for 8's, we break off the last 3 digits. And we're going to do some long division with that number, with the number 224. So I'm going to take 224, and I'm going to divide by 8 to see if I get a remainder. So 8 goes into 22 twice for a total of 16. And I have a remainder there of 4, 5, 6. Drop a 4. And 8 goes into 64 perfectly, hey, with no remainder. So that tells us that indeed, no remainder, it divides perfectly, so yes. 58,224 is a multiple of 8. So here's the good and the bad news about this trick, guys. You guys can already see that it's only useful if you have a great big number, because I'm still doing long division, but I'm only doing long division with the last 3 numbers. So take it or leave it. I don't know how helpful the 8's is to you, but I didn't want to rob you of the chance of knowing what the trick was. So we won't spend a lot of time focused on this, but I did want to give you a shot at it. So we'll do a couple more of these, and then we'll look at all our divisibility together. So is 8 a factor of 60,756? So once again, we'll break off the final 3 digits, divide by 8, and let's see what happens. 8 goes into 75, what's that, 9 times. And 9 times 8 is 72. Subtract, we've got 3, drop a digit, 9. 8 goes into 36 4 times, but look at that. I've got a remainder. So y'all know the rule already. Remainder means we do not have divisibility. And so is 8 a factor? Nope, sorry. One last problem. Is 306,946 divisible by 8? Same basic concept. Let's try our division. 8 goes into 9 once with a remainder of 1, drop a digit. 8 goes into 14 once again, but this time we've got a remainder of 6, drop a digit. And how many times does 8 go into 66? Well, that's 8 times, but 8 times 8 is 64, so I have a remainder. And so my answer here is no. Okay guys, I do have a homework in Quizlet for the divisibility tricks for 8's. It's 1.4L, but for the first time ever, y'all lucked out. This one's actually optional. I'm going to tell you the truth, I don't care that much about the trick for 8's. Wanted to show it to you so that you would understand it. It makes sense, but like I said, it's only useful with really, really large numbers. And we don't usually see that many large numbers on this test. So there you go. Give it a try if you want. I've decided to be kind and full of light since this is light and salt learning. And so that you don't have to go searching through 4 or 5 different videos for all our rules. I've summed up all the divisibility tricks right here. So you can take these down and have them all in one place if you care to. That way when you do your homework for this lesson, you won't be too stressed out. A couple things I want to remind you of. I want to remind you that it's really, really easy to look for 2's, 5's, and 10's because those are all final digit tricks. Those are the easy ones to see. And I also want to remind you that the tricks for 3's and 9's are what we call sum of digit tricks. So you're going to have to add in order to be able to see their divisibility. Okay? 2 other things I wanted to point out to you. 1, I didn't make a video about the 6's. Haven't really spoken to you much about them, but I did write down the trick for those of you who are curious. 6's, the number 6, what is it made of? Again, I always ask myself what a number is made of to find out how it's going to behave. Well, 6 is made of 2 times 3. And because of that, if you'd like to check for a 6, real quick check, you'll just run the 2's check, is it even? And the 3's check, does the sum of digits, is it divisible by 3? And so I've written it here, even and sum of digits. And I think I'll give you a bonus problem right here. If you can follow me on over here. Let's do is 342. Can you tell I was having to think about that one, guys? divisible by 6. So once again, 6 is made of 2 and 3, so I'll run both of these checks on this number. First thing, is my number even? And then notice it ends in 2, so the answer is yes. But second thing, I have to ask myself another question. Is the sum of digits divisible by 3? So I'm going to go ahead and sum those digits. This will be a nice review for you guys about this trick. Sum means to add. So 3 plus 4 is 7 plus 2 is 9. Ask yourself, does the sum of digits divide by 3? Does 9 divide by 3? Well, heck yeah, it does. 3, 6, 9. So the answer to this question is yes as well. So we have 2 yeses. We have a yes on 2 and a yes on 3, which means indeed 342 is divisible by 6. Great. Y'all saw that one in action. So come back over here. Showed you the 6 trick. And then I wanted to tell you about the number 7. And I have no idea why anybody calls 7 their lucky number. Because as far as I'm concerned, 7 is a little snot. 7 is the only number that I'm going to go ahead and say there's no trick. Now, I once did have somebody tell me there was a trick for 7s. And they showed it to me, and it was so complex that I said it wasn't useful. So I'm going to just go ahead and say there's no useful trick for 7s. And so, guys, you know what that means. If there's no trick to find it, you need to memorize your 7 times tables. We talked about this before. I want to say it again. If you don't memorize anything else, memorize your 7 times tables. Okay, good luck on your divisibility tricks. They are going to come in handy in so many situations. Here is the homework, and this homework is very critical to your learning, guys. A lot of people have the issue that divisibility is actually too easy of a concept. And I know what you're thinking, how can it be too easy? Well, what happens when it's really easy is you see me do it, and you think, oh, that's easy. I don't need to practice that. And you don't practice, I already know. I know, I'm looking at you. And then you don't remember. And what happens is it gets all mixed up. I ask you later, what's your divisibility trick for 3's? And you go, I don't remember. I remember it was easy. So what you need to do is you need to go to set 1.4M in Quizlet. This one's mixed divisibility. I've got all the tricks all mixed up. 2's, 3's. There's divisibility even for 7's. So use all our rules. Try flipping back and forth between the tricks. See if you can really get them down. And remember, guys, if you forget your trick, there's always long division. Okay, have fun.